Hey there, let's look at the definitions of some difference, product, and quotients of functions. Basically, you're accustomed to having the notation f of x for a function and g of x. So we're going to let those guys be any two functions. Take your pick. And then we're creating these new functions, and notice again something I pointed out before, the notation is this is the new function's name, and then it's of x. So there's your input. Okay, so this new function is f plus g of x. We'll define the new function as, intuitively as, f of x plus g of x, satisfying of course the domain of f and g. F minus g of x will be defined as f of x minus g of x. Fg of x will be defined as the function f of x times the function g of x. And finally, f divided by g of x will be defined as f of x divided by g of x, certainly provided that g of x is not equal to 0. Okay, now as far as domain goes, all of these have independent statements about these two functions. So your domain on all of these three anyway, is the intersection of the domain of f with the domain of g. In other words, you want them both to be satisfied. And the same thing is true down here with the extra stipulation that you don't want to divide by 0. Okay, so noting these definitions, let's do the following problem. It says find the values of the given functions. If f of x is x plus 4 and g of x equals x squared, what is f plus g of 4? The best thing we can do is follow our rules. This is defined as f of 4 plus g of 4. And f of 4 is literally 4 plus 4. Do parentheses for emphasis. And g of 4 is literally 4 squared. Okay, so if a calc pad were available, you wouldn't need to simplify. In this case, you can see that the box is smaller. Probably means the calc pad won't pop up, but we can do this. This is 8 plus 16 or 24. Okay. All right, likewise, f minus g of 4 is defined as f of 4 minus g of 4. F of 4, again, is 4 plus 4, minus g of 4, again, is 4 squared, using the formula for g. And we have 8 minus 16 for an n value of negative 8. Okay. Fg of 4 is f of 4 times g of 4. F of 4 again is 4 plus 4. G of 4 again, using the formula, is 4 squared. So we have the value, again, of 8 times 16, or 128. And again, if you had the calc pad, you wouldn't have to go, to this much trouble doing the calculations. Okay, lastly, f divided by g of 4 is f of 4 divided by g of 4, provided g of 4 is not 0, and we've already seen that it is not. F of 4 is 4 plus 4 divided by g of 4, which is 4 squared, leaves us with 8 divided by 16, which is fine as an answer, or 1/2. Okay, so this is an example of just simply using the definitions and evaluating at a certain x coordinate. Now what if you're given instead two graphs and asked to do the same thing? So you want, for example, in part A, you're given a graph of f, you're given a graph of g, you have ordered pairs for each, and you want to do f plus g of 4. So you'll have f of 4 plus g of 4. Well, this means I need to go to my graph, find the value x equals 4 on the graph of f, and calculate the y value that goes along with that guy. And then similarly on the graph of g, find the value of 4, look at the ordered pair, and get the y coordinate. So here we would have 4 plus 0 for a total of 4. And then in a similar manner, f divided by g of 3 means f of 3 divided by g of 3, provided g of 3 is not 0. Okay, f of 3 means we go to the graph of f, look at x equals 3, find the y value, which in this case is 2. And for g of 3, we go to the graph of g, find x equals 3, and locate the corresponding y value, which in this case is 1. And 2 over 1 would actually give us the value of 2. Okay, so you should be able to read from a formula or from a graph. And if you can read from a graph, you could also read from a table. So for example, while it's not done this way in this problem, you could have been given a table, and I'll just draw the f of x guy, where you were given values that x equals 0 goes to y equals 4, or x equals 1 goes to 2, x equals 2 goes to 0, 3 goes back to 2, and 4 goes to 4. For example, you could have been given tables and you could do this problem in a similar manner.